Hello, I'm Nargis Bisset, Project Manager and QA Engineer of the SPYNDoctors, and I will be presenting the third deliverable Team Progress Report. The project idea comes from our mentors, Dr. Jeffrey Duncan and Dr. Kyla Davis from the Utah Department of Health. They want us to develop the web service which should take advantage of the certain elements of Utah medical informatics infrastructure, which is famous among medical informatics professionals for its sophistication and great achievements. Diagram demonstrates three Utah infrastructure systems and how they expected to interact with each other for this project. EpiTrax is an application that provides users and medical professionals with access to data on infectious diseases. It will be a client to the web service we are developing. We are implementing a new feature for this application, which is an access to information about the causes of death and other details. This information is stored in a different database, Eden. However, in order to retrieve information from this database on the basis of general personal data available to our client EpiTrax, we first have to match that personal information using the third important Utah database system, which contains keys to various databases, including Eden. In essence, our web service will take personal data from the client, match this data to individuals in DOH MPI, retrieve the key to the Eden record about the death of this individual, and return this information back to requesting client. We decided to implement this web service as Java web application based on Jersey implementation of JAX RS running in Tomcat Java web service. So now we implemented the major functionality. Our web service is, of course, a 100% back-end operation running on the server. In order to illustrate its use, we provided a simple web form to test it. And this slide shows a sample input and output of a query. Our mentor specified that the first name, last name, and date of birth should always be provided. It is also expected that either gender or street number and street name are provided as well, which is shown in this form. In addition, a number of optional fields may be given to narrow down the possible matches to individuals. In this example, we see that the name, date of birth, and gender were sufficient to provide a unique match to an individual in the DOH MPI. This individual's record in Eden was retrieved and cause of death was returned along with the detailed personal information as recovered from DOH MPI. This slide shows the flowchart illustrating the logic behind the matching decision based on client input and personal data available in DOH MPI. It looks somewhat intimidating, but it is necessary because there could be several possible outcomes of the query, such as incorrect or incomplete input data, no unique match in DOH MPI, unique match in DOH MPI, however, no such entry in Eden, and finally a successful outcome, unique match in DOH MPI, and then match and retrieval of death data from Eden. So if at least the unique match in DOH MPI was found, our service returns output of golden personal information from DOH MPI and possibly also Eden data. Those queries which did not yield unique matches in DOH MPI according to requirements are saved in a special unmatched requests table for future analysis and improvement. This is the presentation of RESTful API of our web service. Its main operation uses POST method, which accepts both required and optional parameters. We also provide a simplified GET method, which can accept only the first name, last name, date of birth, and gender. The Gantt chart shows that the last 2 weeks were filled with the active development work, during which we implemented the major part of the project. We are now actively testing various cases and debugging the code and planning some final improvements in the code while figuring out the way to submit it using Docker according to the project submission requirements. Thank you very much for your interest in our work.